Yes, pi is a term used for symmetry. And symmetry is very important to obtain or establish the molecular orbitals. So same symmetry possessing orbitals only will combine. So pi is one of the general term used for the symmetry of the atomic orbitals to produce various molecular orbitals. Let us know the establishment of various molecular orbitals having pi symmetry by means of LCAO principle.
Let us understand the interaction between the px orbital of the one atom and px orbital of other atom. As per LCO method, three essential conditions are there. Combining atomic orbitals should be of same energy or similar energy. We are talking about the orbitals of the atoms of same element. So their energies will be same. So 2px orbital of one atom and 2px orbital of other atom energy will be same. So first condition is allowing to form molecular orbitals. Second condition, combining atomic orbitals should be of same symmetry. Let us find symmetry of those orbitals. Internuclear axis is represented by the dashed line. And px orbital we are considering, one lobe is pointing towards us and one lobe is away from us. So one lobe will be positive, other lobe will be negative. Let us consider a lobe towards us is negative and away from us is positive. If we rotate that px orbital around the internuclear axis, one time rotation will lead positive lobe will come to negative and negative lobe will come to the positive. So exchange of wave function, exchange of wave phase will be there. So wave phase doesn't remain uniform. Wave phase doesn't remain the same. So it is not symmetric about internuclear axis. It is not symmetric about cylindrical axis. So it is represented by symmetry pi. Therefore, this px orbital is called as pi symmetric orbital. Then resultant molecular orbitals of course will be of pi symmetry. Just verify the representation is given there. You can work on that point. So, as per LCO method, two atomic orbitals are combining, two molecular orbitals will be the result. One will be the bonding, other will be the anti-bonding. One where there will be the addition, other where there will be the subtraction. One where there will be the constructive interference, other where there will be the destructive interference. One orbital will decrease in energy compared to the atomic orbital's energy, and other orbital will increase in energy. The orbital of low energy is called bonding molecular orbital, that will help for bonding, and the orbital of high energy is called anti-bonding molecular orbital, that will oppose for the bonding. So if I were to obtain bonding molecular orbital, then constructive interference addition should be there. So the lobes which are parallel to each other means the lobes which are away from us, both orbitals lobe should be positive so that they will combine laterally. They will overlap laterally to produce large positive phase. And the lobes towards us both should be negative so that they can overlap laterally and can produce large negative phase. So bonding molecular orbital will be the one large lobe positive away from us, large lobe negative towards us. It is of pi symmetry, so representation pi 2px. Now come to the antibonding molecular orbital. Antibonding molecular orbital can be resulted by subtraction, by destructive interference. So combining atomic orbitals lobes should be with different phases. So left side atomic orbital, if lobe I consider positive, which is away from us, the right side atomic orbital's lobe, which is away from us, will be negative. So positive, negative, as they come closer, there will be repulsion. So see the angular separation, see the angle made by them, see the repulsion caused there. You can understand by pictorial presentation of antibonding molecular orbital, those lobes are repelling each other. Similarly, let us consider the left side orbital lobe towards us with wave function negative, and right side orbital lobe which is towards us positive. So negative positive will come together, attraction repulsion, repulsion, and therefore the angular separation will be there between them, and that's a representation of anti-bonding molecular orbital. How do we represent anti-bonding molecular orbital? By asterisk. What kind of symmetry those orbitals have? Pi. So pi 2px asterisk is a representation of antibonding molecular orbital resulted due to pi interaction. So pi is the other kind of symmetry you come across. Anyhow, we are following the LCAO method. Concept of pi interaction will be the more clear by this example. Let us consider py orbitals from each atoms. Those are up down. Three essential conditions to form molecular orbitals. Number one, combining atomic orbitals should be of same or similar energy. Since we are considering homonuclear diatomic molecules, the energies of py orbital of one atom and py orbital of other atom will be same, so they are eligible to form molecular orbitals. Second condition, combining atomic orbitals should be of same symmetry. About internuclear axis, if we rotate the orbital, then we will find that a positive lobe will come to negative or negative lobe will come to the positive side. And that will be the case for any py orbital. So both have same symmetry. Therefore, these orbitals are suitable to form molecular orbitals. So py and py can interact to produce molecular orbitals. But one more condition, last condition, there should be appreciable overlap. Yes, we are considering these are the outer orbitals. Therefore, the appreciable overlap will be there. So all three essential conditions to form molecular orbitals are fulfilled. Molecular orbitals will be established. First, by additive interaction, constructive interference. Which orbitals will be resulted? Bonding molecular orbitals. How can they be resolved? So positive lobe of one and positive lobe of other, they will interact laterally. Constructive, additive interference to produce large positive lobe, which is upper lobe, represented by white coloration. And negative lobe, that's a lower lobe of one orbital, will interact with negative lobe of other orbital to produce large negative lobe. It is a pi kind of orbital, pi symmetry orbital produced due to 2py. Therefore, pi to py is a representation for that bonding molecular orbital which is of low energy. What about antibonding molecular orbital? There, combining atomic orbitals, lobe should be different. So, upper lobe of one orbital will be positive, then upper lobe of other atom will be negative. So positive, negative, there will be repulsion. So those will separate each other. Angular separation you can realize. Similarly, lower lobe, if one is positive, other will be negative. I am considering here the left side lower lobe is negative and right side lower lobe is positive. So repulsion between them will be there, causing butterfly kind of the structure, which is a representation for anti-bonding molecular orbital. But pi kind of symmetry is there. So how can we represent that? Pi asterisk 2py. For more clarification, you can work on the resultant molecular orbitals and see their symmetry, whether it is pi category or sigma category by rotation around internuclear axis. What is our logic? By rotation around internuclear axis, if we find the change in wave function, then there is a pi kind of symmetry. And if there is no change in wave function, sigma kind of symmetry. So s orbital, pz orbital, py orbital, px orbital, all orbitals interaction we have discussed. If I recap, we understood the pz-pz interaction is a sigma interaction to produce one bonding, one antibonding. Similarly, px-px is pi interaction to produce one bonding, one antibonding. Accordingly, py orbital produces one bonding and antibonding molecular orbitals. Extent of interaction of px and py is same. Therefore, resultant bonding orbitals because of pi interaction of px and resultant bonding orbital because of pi interaction of py both will be of same energy. We say they are degenerate. While antibonding orbital produced by pi interaction of px and py, they also will be of same energy. So they will be degenerate. I want to compare now interaction between pi symmetric atomic orbitals and Sigma symmetric atomic orbitals means interaction between pz orbitals and px or py orbitals. What do you think? Where will there be more interaction, strong interaction, more overlap? Yes, since PZ is an axial orbital and it is an internuclear axis, those two atoms are approaching along the PZ direction. So there will be the strong interaction, head-on head collision, head-on head interaction, more overlap will be there. Therefore, stability of bonding orbital caused by PZ will be more. Accordingly, unstability of antibonding orbital also will be more. Other way, stability of bonding orbital caused by pi interaction between px and px or py and py will be less compared to stability of sigma pz. Accordingly, antibonding orbital instability also will be less compared to the instability of the antibonding pz orbital. It is our expectation. But in true sense, in MO diagrams, energetic is different. What is our expectation? Sigma Pz should be there as lower energy, then pi px and pi py orbitals, then pi star px and pi star py orbitals, then sigma star pz orbital. That should be the energy sequence. But in true sense, in molecules, energy sequence may vary. The reasons are there. Detailed reasons you will come to know exactly next year. But in this year, let you know the changes in the energetics. The concept will be more clear in the next lecture. But I wanted to say sigma is a strong interaction than pi, therefore stability of sigma should be lower than that of the pi orbital. But molecular orbital diagram or molecular energetics is a complicated aspect. As a homework, one interesting question. What we learned from LCAO principle, symmetry if it's same for the combining atomic orbitals, molecular orbitals will form. And only two kinds of symmetries we have studied, sigma and pi. If I consider px orbital of one atom, what is its symmetry? Pi. Py orbital of other atom, what is its symmetry? Pi. So these px and py of these two atoms, can they combine to produce molecular orbitals? Is my question. For diatomic molecules, px and py have pi symmetry. Then as per LCO principle, can px orbital combine with py orbital to produce molecular orbital? Answer yes or no. I hope question is clear.
Now we understood how LCAO principle is used to establish the sigma category and pi category molecular orbitals or molecular orbitals from sigma category atomic orbitals or pi category atomic orbitals. Various types of molecular orbitals. What are the essential conditions that we understood? Means of course LCAO method. Now it is the right time to apply the principle, LCAO principle for various molecules. Let us apply it for few molecules from next part.